JScent is a program analyzer that detects code smells. Code smells are potential issues with source code that can correspond to a deeper problem in the program. For example, JScent can detect issues such as long methods, too many comments, feature envy, message chains, dead code, and more. While these may not affect the execution of the program, at times they even improve code execution. They make the code harder to read, maintain, and extend. JScent attempts to fix this problem by highlighting selected code smells and suggesting to the programmer how code can be improved. JScent produces a report that summarizes all the code smells found in a concise and usable way. JScent completes a static program and meta-property analysis that is value agnostic. JScent is aimed at developers and teams who are trying to build code that is maintainable, extensible, and well-structured. The reports generated are not intended to be prescriptive, but rather point out areas that may be cause for concern as a project grows in size and scope. Our goal with the project was to provide insight into non-trivial code smells, which influenced the design of our project. We initially thought of treating each input file as a set of statements that could be processed using regex to detect code smells, but we quickly concluded that this approach would not be robust enough. With this approach, we would not be able to detect non-trivial code smells. We decided to get our hands dirty and implemented an advanced JavaScript parser. With over 65 different JS nodes, we split the implementation of the project evenly while some of us worked on the video and user studies. In our task-driven user study, participants were given a report and a code base. They were asked to provide feedback on how easy it was to find the code smells using the report. Our users mentioned that not enough detail was given as to where the smell was located. So upon implementation, we made sure to indicate the line and character numbers of the issue in question. For our final user study, we gave 2 novice programmers a JS codebase. We asked one of the participants to identify any visible issues with one of the classes and highlight some of the improvements they could make to the code for it to be easier to read and maintain. 2 issues that this participant mentioned were a method with a long parameter list and a long method chain in the code. We asked this user for feedback on how easy it was to identify this issue, and the user said that it took them longer because they spent some time trying to understand what the code does. For the other user, we gave them a JS codebase and instructions on how to run our analyzer program on one of the classes. It took this user way less time to identify the issues identified by our other participant. They said that it was easy to find the issues and act on them. This participant also added that they thought it was quite a useful tool to have, especially as a codebase grows. In conclusion, JScript has ended up being a very helpful tool for detecting code smells in programs. This analyzer allows programmers to write maintainable and extensible code on the fly. Using the feedback from our user studies, we were able to build reports that users truly benefit from.